What if I told you there's a hole in the universe so large it could swallow up 1,000 galaxies the size of the Milky Way and still have room to spare? A place where, instead of glowing stars, swirling galaxies and radiant clusters stretching across the cosmic web, there is simply nothing, not empty space in the way we normally think of it, dotted with the occasional faint galaxy or streak of dust, but an almost unimaginable abyss where entire swaths of the universe seem to have vanished. Astronomers call this haunting region the Bootes Void, and when it was first discovered in 1977, it didn't just puzzle scientists, it terrified them. It was so enormous, so empty, and so contrary to the laws of cosmology that some wondered if we had stumbled upon a glitch in reality itself. To look into the Bootes Void is to stare into a cosmic desert, a place where the rules of the universe appear to have broken down, and the deeper scientists studied it, the more disturbing the mystery became. From Earth, when we gaze at the night sky, we expect to see structure everywhere. Through telescopes, the universe reveals itself as a vast cosmic web. Galaxies clustered together like shining cities seen from above at night, connected by filaments of dark matter, separated by voids, but never completely alone. That was the model. A universe filled with matter, more or less evenly spread on large scales, forming a balance between light and dark, emptiness and fullness. But the Bootes Void shattered that vision. Imagine standing at the edge of a vast parking lot in the middle of Manhattan, expecting to see thousands of cars, and instead finding only a handful scattered across the asphalt. The silence would feel wrong. The emptiness would feel unnatural. That's what astronomers felt when they mapped the Bootes Void, a yawning expanse 330 million light-years across where galaxies simply weren't. To put that in perspective, light traveling at only 6,000 miles per second would still need more than 300 million years just to cross it. This isn't an empty neighborhood in space, it's an entire metropolis missing from the universe's map. The shock was immediate and profound. According to the models of cosmic evolution, voids were supposed to exist, but they weren't supposed to look like this. Voids should still contain thousands of galaxies, just more sparsely distributed than in clusters. But in the Bootes Void, where 2,000 galaxies should have glittered, only 8 could be found. 8 lonely islands of stars adrift in a cosmic ocean of nothingness. Scientists soon began calling it the Great Nothing, and the name stuck, because nothing else quite captured its bizarre reality. And these 8 galaxies, the so-called survivors, were just as strange as their surroundings, isolated, faint and stunted in growth, like children raised in permanent solitude. Everything about this place seemed wrong. But what makes the Bootes Void even more disturbing is not just its emptiness, but the possibility that it is still growing. The evidence suggests that the void is expanding faster than the universe itself, as if emptiness is contagious, spreading across the cosmos like a shadow. Galaxies at its borders are packed tighter than usual, as if they're fleeing from the void's center. It's as though the universe itself is trying to escape from this great hole, and that unsettling truth forces us to ask questions humanity has never dared to confront. Why does this void exist? Was it carved out by forces we cannot yet detect? Is it a natural part of cosmic evolution, or could it represent something deeper, a crack in the very fabric of reality? When Robert Kirshner and his team first pointed their telescopes toward the constellation of Bootes in the late 70s, they expected to find the familiar glow of galaxies stretching into infinity. Instead, they found silence. No light, no structure, no matter, just an endless nothing that forced them to redraw the boundaries of what we thought we knew about the universe. The Bootes Void is more than a hole in space. It's a challenge, a cosmic riddle, and perhaps even a glimpse into the future of the universe itself. Because if dark energy continues to accelerate cosmic expansion, if galaxies keep pulling away from one another, then in the far future, all of reality may look like the Bhute's void, empty, dark, and alone. So what exactly is hiding in this abyss? How did it form? And what secrets do the lonely galaxies trapped inside it hold? The answers may forever change the way we think about existence. Because in studying this great nothing, scientists have uncovered clues not only about how the universe evolved, but about how it may one day end. In 1977, a group of astronomers led by Robert Kirshner began a survey of galaxies in the constellation Bootes, a task that should have been routine. Their instruments swept across the sky, plotting the positions of galaxies as tiny points of light. But as the data poured in, something unusual began to appear on their charts. An enormous region where there were no galaxies at all. At first, they assumed it had to be a mistake, an equipment error, an observational oversight, perhaps even a patch of sky that hadn't yet been properly scanned. But the more they checked, the stranger it became. Everywhere else, galaxies were scattered like glitter across black velvet. Here, though, was a vast patch of darkness where nothing seemed to exist. When the final maps were drawn, they revealed a hole so enormous and so empty that it contradicted everything cosmologists thought they knew about how the universe was structured. You have to understand what made this discovery so disturbing. By the mid-20th century, the idea of the cosmic web was already emerging. Galaxies were not randomly scattered, but instead formed interconnected filaments, with dense clusters linked together and emptier spaces, voids existing between them. But even these voids weren't supposed to be truly empty. They still contained galaxies, just fewer of them. The Bootes region, however, was different. When astronomers pointed their telescopes into this abyss, they didn't see the faint smudge of distant galaxies or the scattered glow of star clusters. They saw nothing. A void so big it spanned 330 million light-years, dwarfing anything else of its kind ever observed. To put it simply, this discovery broke the rules. Imagine the universe as a night sky viewed from an airplane flying over a sprawling city. You expect to see lights everywhere, bright clusters where cities are, and dimmer patches where towns scatter across the landscape. But the Bootes void was like looking out and seeing an enormous stretch of total darkness, the size of an entire country, with just a few lonely pinpricks of light scattered within it. The absence wasn't subtle. It was blatant, and that blatant emptiness meant one of two things. Either our understanding of how the universe formed was flawed, or some unknown force was at play. Neither possibility was comforting. The first surveys suggested that the Bootes void should have contained around 2,000 bright galaxies, given its volume and the average distribution of matter. Instead, only 8 were found. 8 tiny survivors adrift in an ocean of nothingness. The silence of this cosmic desert was deafening. To the scientists, it was as if the universe had deliberately erased a section of itself. Some called it the Great Nothing. Others referred to it as the cold spot, but the name that stuck was the Bootes void, forever linking this terrifying discovery to the otherwise ordinary constellation in which it was found. What made this void even more alarming was the timing. The 1970s and 80s were decades when cosmology was beginning to piece together the first large-scale maps of the universe. Computers were becoming powerful enough to run simulations of cosmic structure, and those simulations all predicted a universe that was relatively uniform on the largest scales. Galaxies should have been evenly spread out, with voids and clusters balancing each other. But here was a void so extreme that it shouldn't have existed at all. The probability of such a region forming by chance, based on the physics of the Big Bang and the subsequent evolution of matter, was less than 1 in a million. And yet it was there, staring back at us from the sky, daring us to explain it. When Kirshner and his colleagues first published their findings, the reaction from the scientific community was mixed. Some dismissed it as an observational error, something that would surely vanish as better instruments filled in the gaps. Others realized that if the void was real, it would force a re-evaluation of everything we thought we knew about cosmic structure. Follow-up surveys with more powerful telescopes confirmed it. The Bootes void was no illusion. It was real, it was vast, and it was empty. And yet, even in this emptiness there were survivors. A handful of faint, lonely galaxies clung to existence within the void, like solitary lighthouses on an endless dark sea. But these survivors were not normal. They were stunted, underdeveloped, and strangely isolated, unlike anything seen in more crowded regions of the cosmos. Their very existence raised new questions. How could they form in such a barren environment without the gravitational scaffolding of nearby galaxies to help them grow? And what hidden forces had left them stranded in the heart of this cosmic desert? The discovery of the Bootes void wasn't just another entry in the catalogue of cosmic structures. It was a shockwave, a direct challenge to the very foundations of cosmology. It showed us that the universe still holds secrets, vast enough to humble even the most confident scientific models. And it was only the beginning. Because once scientists looked deeper into the void, they realized the mystery was far stranger than they had ever imagined. To understand why the Bootes void is so unsettling, you first have to grasp its sheer size. This isn't just a gap between galaxies or a slightly underpopulated corner of the cosmos. It is one of the largest known structures in the entire universe. The Bootes void stretches across an astonishing 30 million light-years. That means if you could travel at the speed of light, 86,000 miles per second, it would still take 30 million years to cross from one side to the other. For comparison, the Milky Way galaxy with its 100 billion stars is only about 100,000 light-years across. You could fit thousands of Milky Ways end-to-end inside the Bootes void and still not come close to filling it. This isn't emptiness on a human scale, or even on a galactic scale. It is emptiness on a truly cosmic scale. Analogies help put this in perspective. Imagine shrinking the Milky Way down to the size of a quarter, toss it into the Bootes void, and to even begin filling that emptiness, you'd need 999 more quarters just like it. And even then, the vast majority of the void would remain untouched. Another way to picture it is like standing in the middle of New York City, expecting to see skyscrapers, lights, and bustling crowds, only to find an empty parking lot stretching for thousands of miles in every direction. That sense of wrongness, of absence where presence should be, captures what makes the Bootes void so strange. The numbers only get more staggering the closer you look. Astronomers calculated that, based on the average density of the universe, there should be around 2,000 galaxies inside the Bootes void. Instead, only 8 have been found. Imagine walking into a concert hall built to seat 2,000 people and seeing only 8 scattered individuals in the darkness. The silence would be oppressive, the space unnatural, the emptiness overwhelming. That's what the Bootes void represents. An auditorium of the cosmos where the crowd never showed up. And this emptiness isn't just eerie, it's statistically improbable. Our models of the universe, based on the Big Bang and the growth of structure over billions of years, predict that matter should spread out relatively evenly across such vast distances. Yes, there will be clusters and voids, but not on this scale, not this empty, not this extreme. The probability of a region like the Bootes void forming by random chance is less than 1 in a million. which means either the void is a cosmic fluke of almost impossible odds, or something about our understanding of how the universe works is incomplete. Both possibilities are equally disturbing. The scale of the void also creates peculiar effects at its boundaries. Around its edges, galaxies are packed tighter than normal, almost as if they're fleeing from the emptiness inside. It's as though the void itself is repelling matter, pushing galaxies outward and clustering them along its borders. This clustering forms massive walls of galaxies that stretch across hundreds of millions of light years, enclosing the void like the walls of a prison. The Bhuta's void, then, isn't just an absence. It's a presence in its own right, shaping the distribution of galaxies around it, bending the structure of the cosmic web into unnatural forms. And what makes this even more chilling is the possibility that the void is not static. Observations suggest that it is expanding slightly faster than the rest of the universe, growing emptier over time. This means that not only is it vast and lonely, but it's also alive in a sense, an emptiness that feeds on itself, pulling more matter away as it evolves. If that's true, then the Bhuta's void may not just be an odd feature of our universe, it may be a preview of its destiny. Because if dark energy continues to accelerate the expansion of space, then billions of years from now, the entire universe may look like the Bhuta's void, cold, empty, and isolated. This scale forces us to confront a terrifying thought. In the Bhuta's void, galaxies are so isolated that they might as well not exist. The nearest neighbor to a void galaxy can be 50 million light-years away, compared to just 2 million for our Milky Way and Andromeda. That kind of distance means no meaningful interaction, no galactic mergers, no exchanges of matter. A galaxy trapped in the void is a hermit in every sense, cut off from the cosmic society that most galaxies inhabit. They are alone in a way that is almost incomprehensible. So when scientists speak of the Bhuta's void, they are not just describing an empty patch of sky, they are describing one of the largest holes in existence, a region so vast that it challenges the very framework of cosmology. It is an abyss not just in space, but in our understanding. A reminder that even on the grandest scales, the universe still contains mysteries that can leave us speechless. And yet, despite all this emptiness, something remains inside the void. A handful of galaxies, faint and strange, clinging to survival in defiance of the nothingness surrounding them. And these survivors may hold the key to understanding not just the void, but the forces that shape the universe itself. If the Bhuta's void were truly empty, its mystery would already be staggering enough. But what makes it even stranger is that it isn't completely devoid of galaxies. Scattered across its vast interior, like lonely ships on a dark ocean, are 8 survivors. 8 galaxies where there should have been thousands. Their existence is as baffling as the emptiness that surrounds them, because they don't behave like galaxies in normal parts of the universe. In fact, they seem to have been shaped by their isolation, warped by a cosmic environment so empty that it has left scars on their very nature. In the broader universe, galaxies live in crowded neighborhoods. The Milky Way, for example, sits in a bustling community called the Local Group, with more than 50 nearby galaxies and Andromeda only 2.5 million light-years away. Galaxies in these environments constantly interact. They tug on each other gravitationally, exchange streams of gas, and sometimes collide and merge, sparking bursts of star formation. These interactions are part of what makes galaxies thrive and evolve. But the survivors of the Bhuta's void have none of this. The nearest neighbor for a void galaxy is usually around 50 million light-years away. That's 20 times more isolated than the Milky Way. Imagine living in a city where the nearest other person is on the opposite side of the planet. That's the level of loneliness these galaxies endure. This profound isolation has consequences. The void galaxies are smaller and dimmer than they should be, their growth stunted as if the emptiness around them has drained their potential. Many of them contain far fewer heavy elements compared to galaxies of similar age outside the void. That's important because heavy elements, like carbon, oxygen, and iron, are created when stars die and spread their material into space. In crowded environments, galaxies share these materials, enriching one another over time. In the void, though, the galaxies are cut off. They recycle only their own limited resources, producing stars at unusually low rates. It's as though they are trapped in permanent adolescence, never able to reach the maturity of fully developed galaxies. Astronomers call this effect galactic underdensity, a sterile term that doesn't do justice to the strangeness of what's happening. These galaxies are not just lacking in matter, they are lacking in community, in connection, in the cosmic society that shapes normal galactic evolution. They are hermits in the truest sense, drifting alone in a sea of silence, evolving down a path so different that it challenges our definitions of what a galaxy even is. Their very isolation seems to warp their identity, leaving them less like thriving cities of stars and more like quiet outposts, clinging to existence at the edge of a desert. And then there's their arrangement. The Bootes, void galaxies, aren't scattered randomly throughout the emptiness. Instead, they are lined up in a strange tube-like formation, as if connected by an invisible structure. Astronomers describe this as a filament, a kind of cosmic highway along which galaxies are strung like lights on a wire. But here's the problem. In normal regions of space, filaments are created by the gravitational scaffolding of dark matter, which guides galaxies into clusters and webs. In the Bootes void, however, the dark matter framework appears to be missing, or at least dramatically reduced. So how can these galaxies line up so precisely in such a barren environment? It's as though an unseen hand has arranged them, marking a path through the emptiness that should not exist. Even more unsettling, these galaxies don't just sit still. Their motions suggest they are all drifting in the same direction, as if following an invisible current through the void. They move like leaves carried by a hidden stream, responding to forces we cannot see but can only infer. Whether this is the influence of faint traces of dark matter or something stranger altogether remains an open question. But what is clear is that these survivors are not just passive relics. They are active participants in the void's mystery, shaped and guided by forces that defy our understanding. The Bootes void galaxies serve as cosmic time capsules. Because they are so isolated, they preserve conditions that existed billions of years ago, before galaxies elsewhere became enriched and complex through countless interactions. Studying them is like peering into an earlier epoch of cosmic history, a window into what galaxies may have looked like before the universe grew crowded. And yet, they are also windows into the future, because their isolation foreshadows what will happen to all galaxies if cosmic expansion continues to accelerate. Billions of years from now, every galaxy will be as alone as the Bootes survivors, stranded in a universe where the night sky is empty and no other galaxies can be seen. So while the Bootes void itself is terrifying in its scale, its galaxies are perhaps even more haunting. They show us not only how strange the universe can be, but how fragile galactic life truly is. These 8 lonely survivors are whispers from the abyss, testaments to resilience in the face of overwhelming emptiness, and their presence forces us to ask, what invisible forces carved out this desert, and why were only these few galaxies left behind to wander in it? When astronomers first mapped the handful of galaxies trapped inside the Bootes void, they expected them to be scattered randomly, like isolated dots floating in an endless sea of black. After all, if the void is defined by emptiness, then what little matter remains inside should appear without order. But that wasn't the case. Instead, the survivors were found arranged in an eerie formation, stretched out along what looked like a cosmic tunnel. Imagine standing in a subway tunnel in complete darkness, the faint glow of 8 stations evenly spaced across its length, each one a galaxy shining faintly in the void. That is what the Buta's galaxies look like, aligned as if strung along an invisible thread. Scientists call this arrangement a filament, but in this case it is a filament with no obvious cause. Normally, galactic filaments form because of the gravitational scaffolding provided by dark matter. Invisible streams of this mysterious substance weave the cosmic web, pulling galaxies together into strands and sheets that shape the universe's largest structures. But in the Buta's void, the dark matter framework seems to be missing, or at least dramatically reduced. And yet here are galaxies neatly arranged as us following an unseen instruction. This discovery was almost more unsettling than the void itself. Because if galaxies inside a place that should be nearly devoid of matter can still align in such a precise structure, it implies that there is something invisible guiding them. Perhaps faint traces of dark matter remain in the void, stretched thin but still enough to herd galaxies into line. Or perhaps something far stranger is at work. Some have even speculated that the void galaxies could be following currents in the very fabric of space-time, like ships carried by ocean tides. Their motions aren't random. Observations reveal that many of these galaxies are moving in similar directions, their velocity synchronized as though they are all responding to the same hidden influence. It's as if there is an invisible river running through the void, and the galaxies are simply passengers caught in its flow. The existence of this filament raises disturbing possibilities. If dark matter is responsible, then its distribution in the Buta's void is unlike anywhere else in the universe, stretched into a line instead of spread into a web. That would mean dark matter is far more complex than we imagine, capable of arranging itself in ways that defy our models. But if dark matter isn't the answer, then we may be looking at evidence for something entirely new, some force or structure we have yet to detect. Perhaps a remnant from the early universe, a fossil of primordial energy that has survived in the void while being erased elsewhere, or perhaps something even more exotic, a boundary where the laws of physics themselves behave differently. The galaxies themselves show signs of being influenced by this structure. Their star formation rates are low. Their chemical compositions primitive, and yet they persist, aligned in their strange configuration, as if the emptiness around them is shaping their very nature. Studying them is like staring at cosmic hieroglyphs, symbols left behind by forces we do not yet understand. The filament may be a clue to how the void formed in the first place. Some simulations suggest that when smaller voids merge together, they can leave behind thin tendrils of matter that stretch through the emptiness. The Buta's galaxies may be remnants of such a process, fossils of the universe's earliest architecture. But others believe this explanation is too simple. The precision of their alignment, the way they form a tube-like pathway through the heart of the void, is difficult to reproduce in computer models. It feels deliberate, too ordered to be chance. The unsettling truth is that we don't yet know why these galaxies are arranged the way they are. The universe is supposed to be chaotic, shaped by random fluctuations of matter and energy, smoothed out by gravity over billions of years. Yet here, in one of the emptiest places we've ever observed, is a structure that suggests order, a pattern where none should exist. It forces us to question whether the void is simply an absence of matter, or whether it hides an underlying skeleton of reality we have yet to uncover. And if such order exists within emptiness, then what else might be hidden inside the Buta's void? Could there be more than galaxies shaped by unseen forces? Could there be other structures invisible to us, remnants of ancient physics preserved in the silence of the void? The filament of survivor galaxies is a whisper of something greater, something waiting to be discovered. And as astronomers studied the void more closely, they realized that the mystery didn't end with a strange alignment of galaxies. The void itself was changing, evolving, and growing, as though nothingness were not passive, but alive. And what they found next was even more terrifying. The Buddha's void might have been strange enough if it were simply sitting there, a static scar in the fabric of the universe. But what scientists soon realized is even more disturbing. This emptiness is not frozen in time. It appears to be alive, expanding faster than the universe itself, as though the void is actively growing. Normally, cosmic expansion is driven by dark energy, a mysterious force that causes galaxies to drift apart at an accelerating pace. This expansion is uniform across the universe, or at least it should be. But when astronomers studied the Buddha's void, they noticed something peculiar. The galaxies along its boundaries were moving faster than expected, their velocities suggesting that the void was pushing them outward, as if it were repelling matter. In other words, emptiness was spreading. This phenomenon creates what physicists call a void instability. Once a region becomes slightly underdense, matter tends to flow away from it toward areas of higher density. It's a feedback loop. The emptier a region becomes, the more matter escapes, and the more the void grows. It's like a cosmic sinkhole widening over time, swallowing everything near its edges. In the Buddha's void, this process seems to have reached extreme levels. Instead of passively existing as an absence of galaxies, the void acts as if it has its own momentum, a growing hole in space that is accelerating beyond the cosmic average. To visualize this, imagine blowing up a balloon. Normally, every part of the balloon expands equally, but now imagine that one patch of the balloon has a hole, and as the balloon expands, the hole itself also grows, stretching faster than the rest. That's what's happening with the Buddha's void. Over billions of years, it has become more and more empty, its boundaries pushing outward as galaxies flee from the oppressive nothingness inside. And if current models are correct, the void will continue to expand, doubling in size over the next several billion years. By the time our sun burns out 5 billion years from now, the Buddha's void may be twice as large, an even more terrifying chasm in the cosmic map. The question is, why? Why does this particular region seem so eager to empty itself, while other voids remain stable? One possibility is that dark energy is stronger within the void, concentrated in its emptiness like a kind of cosmic vacuum cleaner. If true, then the Buddha's void could be the site of a local fluctuation in the nature of dark energy itself, a place where this mysterious force is amplified. Another theory suggests that the void could be a bubble of false vacuum, a region where the very fabric of space-time is in a different state than the rest of the universe. In such a scenario, the laws of physics themselves might be slightly different inside the void, and that difference could drive the accelerated expansion. If so, the Buddha's void might not simply be a hole in space. It could be a glimpse of a future where the entire universe transitions into a new state of reality. This idea is unsettling because it suggests that the void might be contagious. If the Buddha's void represents a bubble of false vacuum, it could, in theory, expand indefinitely, consuming more and more of the cosmos as it grows. While such an expansion would occur at the speed of light, making it undetectable until it arrives, it raises an existential possibility. Perhaps the Buddha's void is not just an empty region, but the beginning of a transformation that will one day engulf everything. Even without such catastrophic speculation, the reality is chilling enough. The galaxies along the void's borders behave like people pressed against the walls of a collapsing building, clustering together in dense formations, as if trying to stay as far as possible from the emptiness inside. These boundary walls are 3 times denser with galaxies than normal regions of space, a direct response to the void's repulsive pull. The emptiness inside creates pressure on the outside, herding galaxies into walls and filaments that form the very edge of the void. The Boots void is not a static hole then, but a dynamic force in the universe. It grows, it shapes, and it repels. It is emptiness with teeth, carving itself deeper into the structure of the cosmos. And if it continues unchecked, it may offer us a glimpse of our universe's fate. Because in the far future, as dark energy continues to dominate, the cosmic web itself will unravel. Galaxies will drift apart until they can no longer see one another, until every cluster is isolated in an infinite darkness. In that age of ultimate loneliness, the entire universe will look like the Boots void. What we see today in this one region may simply be a preview of tomorrow's reality, a universe consumed not by fire or collapse, but by the slow, relentless spread of nothingness. If the interior of the Boots void is unsettling, the edges are even more fascinating. Around the perimeter of this colossal emptiness, galaxies do not scatter evenly. Instead, they gather into dense walls and filaments, as if they are fleeing from the void itself and clinging together for safety. Astronomers call these formations void walls, and they represent some of the most extreme examples of large-scale structure in the universe. Imagine standing at the edge of an ocean where the sand abruptly gives way to water. That sharp boundary between land and sea is exactly what happens at the border of the Boots void, except instead of sand and waves, it's matter and nothingness. On one side, galaxies crowd together in unnatural densities, while on the other side, there is almost nothing at all. This sharp boundary breaks the rules of cosmology. Matter in the universe is supposed to be distributed gradually, like paint fading from one color into another. Density variations should be smooth, with galaxies thinning out gently as you move into emptier regions. But the Boots void doesn't fade. It cuts off abruptly, a cliff where galaxies suddenly vanish. The transition happens over a narrow zone, perhaps 20 million light-years across, which on cosmic scales is razor-thin. Such sharpness suggests that powerful forces are at work, sculpting the void into a shape that our current models cannot reproduce. Within these walls, galaxies behave strangely. Their motions are faster and more erratic than expected, as though they are being actively pushed away from the void's center. Instead of drifting lazily under the influence of cosmic expansion, they accelerate in peculiar directions, their velocity skewed by some unseen repulsive force. This creates what physicists describe as a negative pressure gradient, a situation where emptiness itself seems to exert a kind of push. The effect is so strong that galaxies caught too close to the boundary appear distorted, stretched or warped, as if they are being torn apart by tidal forces associated with the void. Some of these galaxies may ultimately be consumed, not in the traditional sense of falling inward, but by being pushed outward into more crowded zones, stripped of their structure by the violence of the transition. The void walls are more than just crowded. They are bloated with galaxies. In some places, these boundaries contain 3 times more galaxies than comparable regions of space, clustering together into massive sheets that extend for hundreds of millions of light-years. Picture curtains of galaxies, thick and luminous, pressed against the emptiness, like crowds huddled against the walls of a vast, terrifying chamber. These formations are among the largest known features in the cosmos, comparable in scale to superclusters, but even denser. Their very existence hints that the Boots void is not just an absence, but an active force reshaping the architecture of the universe. And light itself does not pass through these boundaries cleanly. Photons traveling from distant galaxies are bent by the intense gravitational fields of the void walls, producing subtle lensing effects. Background galaxies appear slightly distorted, their shapes warped into arcs and curves, as though we are looking through a cosmic funhouse mirror. This gravitational lensing is further evidence that matter is being unnaturally compressed along the void's edges, squeezed into formations that ordinary cosmological processes struggle to explain. The void walls may also be a sign that smaller structures are being sacrificed to maintain the larger one. Astronomers have identified galaxy groups that appear to be in the process of falling into the void, caught between attraction to their neighbors and repulsion from the emptiness. These galaxies are stretched into elongated shapes, their star formation disrupted as gas is stripped away. It is as though the void is reaching outward, consuming them not by pulling them in, but by forcing them out of their natural orbits and unraveling them at the seams. In this sense, the Bhuta's void behaves like a predator, not in the traditional sense of eating, but by creating conditions that make survival nearly impossible. Computer simulations struggle to reproduce these dense walls. Even when scientists feed the most extreme initial conditions into their models, the results don't match what we observe around the Bhuta's void. The density of the walls, the abruptness of the transition, the speed of the galaxies, all of it points to forces beyond simple gravity. Some suggest dark matter is being displaced in unusual ways, creating invisible currents that herd galaxies into unnatural formations. Others believe the answer lies in dark energy, concentrated within the void and pushing outward more strongly than in surrounding space. Either way, the void walls are proof that something extraordinary is happening at the boundaries of nothingness. To stand at the edge of the Bhuta's void, if such a thing were possible, would be to witness the starkest contrast imaginable. On one side, a sea of galaxies pressed together in desperate density, glowing with the light of billions of stars. On the other side, blackness stretching for hundreds of millions of light years, punctuated only by a handful of lonely survivors. The walls mark the frontier between existence and absence, matter and nothing, and their strange behavior reminds us that the Bhuta's void is not a passive anomaly, but a living structure in the cosmos. It is a hole with edges that bite back, reshaping the universe around it in ways that continue to defy explanation. When scientists confront the Bhuta's void, they aren't just looking at an absence of galaxies, they are staring into a problem of physics itself. The question is not only why this vast emptiness exists, but how it could have formed in a universe that should not allow such extreme underdensity. According to the standard model of cosmology, after the Big Bang, matter was spread fairly evenly, with only tiny ripples, differences of 1 part in 100,000, that served as seeds for all the galaxies, clusters, and filaments we see today. Over billions of years, gravity amplified those ripples, pulling matter together into denser regions while leaving emptier gaps in between. This process explains the web-like structure of the cosmos, with its networks of galaxies surrounding smaller voids. But when it comes to the Bhuta's void, the theory breaks down. A hole spanning 330 million light-years and containing only a handful of galaxies is not supposed to happen. The probability of such an emptiness forming by random fluctuation is less than 1 in 10 million. Statistically, it should not exist, and yet it does. One of the leading explanations points to dark matter, the invisible scaffolding that holds the cosmos together. Dark matter makes up around 85% of all matter in the universe, and without it, galaxies wouldn't have formed at all. Normally, it clumps into filaments, creating gravitational wells where ordinary matter gathers to form stars and galaxies. But the Bhuta's void appears to lack dark matter almost entirely. Gravitational lensing studies suggest that its dark matter density is less than 10% of the cosmic average, far lower than expected. Without that invisible framework, normal matter had nothing to cling to, and galaxies simply never formed there. The few that do exist may have formed on the edges of ancient filaments before being stranded as the void grew. But this explanation only raises more questions. Why is the dark matter missing? Did it never exist in this region, or was it somehow expelled by unknown forces? Some physicists propose that dark energy, the mysterious force driving cosmic acceleration, is concentrated more heavily within the Bhuta's void. Dark energy normally acts uniformly across space, but if it pools in underdense regions, it could create repulsive forces that push both normal and dark matter away. In this scenario, the void is a kind of cosmic wound, where dark energy has hollowed out space and prevented galaxies from forming. Others suggest something even stranger, that the void is a bubble of false vacuum, a region where space-time itself is trapped in a different state. If true, the very laws of physics could be slightly different inside the void, and its expansion could represent the first stage of a transition that might one day spread across the entire universe. There are also theories that connect the Bhuta's void to exotic events in the early universe. Some cosmologists suggest that cosmic inflation, the brief moment after the Big Bang when the universe expanded faster than the speed of light, may have operated differently here. Inflation should smooth out irregularities, but under certain conditions, it can create vast regions of underdensity. The Bhuta's void may be a fossil of such a process, a relic from the universe's infancy. Other possibilities include primordial black holes that evaporated through Hawking radiation, creating expanding bubbles of emptiness, or phase transitions in the quantum fields of the early cosmos that left behind scars in the form of voids. Even Einstein's theory of general relativity is called into question by the Bhuta's void. In regions with almost no matter, space-time curves outward instead of inward, creating negative curvature. This subtle geometry affects how light and even time behave inside the void. Light traveling through it is slightly redshifted, stretched more than it should be, while clocks inside the void would tick marginally faster than those in denser regions. Though these effects are tiny, they are real, and they remind us that emptiness is not nothing. It has structure, it has properties, and in the Bhuta's void, it may reveal aspects of physics we don't yet understand. What unsettles scientists most is that none of these explanations are complete. Dark matter alone cannot explain the void's scale. Dark energy theories remain speculative. Early universe models predict smaller voids, but not one this immense. And modified gravity theories that attempt to bypass dark matter struggle to reproduce the web of galaxies we see everywhere else. The Bhuta's void sits at the intersection of all these puzzles, a glaring anomaly that refuses to fit neatly into any box. Its very existence is a message written across the cosmos in capital letters. Our understanding of the universe is incomplete. The void, then, is not just empty, it is full of questions. It challenges the standard cosmological model. It defies the probabilities, and it tempts us with the possibility that forces beyond our comprehension are at play. To peer into the Bhuta's void is to confront the limits of human knowledge, to realize that there are regions of the universe where our equations falter and our theories fail. And as strange as its emptiness is, what comes next may be even more disturbing, because the Bhuta's void does not only break physics, it also leaves a fingerprint on the very oldest light in the universe. The Bhuta's void does not just disturb the galaxies caught within it, or the structures that surround it. It also leaves its fingerprint on the oldest light in the universe, the cosmic microwave background. This faint afterglow, released when the Bunez was only 380,000 years old, is like a baby picture of the cosmos, showing us how matter was distributed in its earliest days. Normally, the cosmic microwave background looks almost perfectly uniform, with only tiny temperature variations that correspond to regions that would eventually grow into galaxies, clusters and voids. But in the direction of the Bhuta's void, astronomers see something deeply unsettling, a cold spot, a patch of the sky where the background radiation is significantly cooler than expected. At first glance, this doesn't seem like much. The temperature difference is only about 30 millionths of a degree. Yet on cosmic scales, this small difference is enormous because it represents a region that has been underdense since the dawn of time. The cold spot forms through a process known as the integrated Sachs-Wolf effect. As photons from the cosmic microwave background travel across the universe, they pass through regions of varying density. When light moves through a cluster of galaxies, it gains energy falling into the gravitational well, then loses energy climbing back out, with the two effects cancelling out. But in a region like the Bootes void, where density decreases over time, the photons lose more energy climbing out than they gained falling in. The result is a net loss of energy, leaving them cooler by the time they reach us. In simpler terms, the void taxes the light that passes through it, draining energy as if emptiness itself has taken its toll. Over billions of years, this process has carved a distinct cold signature into the cosmic microwave background, one that tells us the void is not just a modern anomaly, but a structure with roots in the universe's infancy. This revelation is troubling because it means the Bootes void is not simply a fluke of later cosmic evolution. It has been there almost from the beginning. The cold spot suggests that this region of space was already underdense when the universe was less than 1% of its current age. That raises difficult questions. If inflation smoothed the universe so thoroughly, how could such a massive underdensity survive? Did inflation operate differently in this region, leaving behind scars that inflation elsewhere erased? Or is the cold spot evidence of something more exotic? Perhaps even a collision between our universe and another during those earliest moments of creation. Some cosmologists have speculated that cold spots in the microwave background could be signs of multiverse interactions, where bubbles of space-time with different properties brush against one another. If that is the case, the Bootes void may be more than just a hole in our universe. It could be a boundary, a scar from contact with another reality. And yet, even within the standard model, the Bootes cold spot doesn't behave quite as it should. Based on its size and emptiness, models predict that the temperature depression should be about twice as strong as what we actually observe. Something is reducing its intensity, softening its shadow on the microwave background. This discrepancy hints that our understanding of how voids evolve and interact with light is incomplete. Perhaps hot gas or energetic processes within the void are partially reheating the photons, masking some of the expected effect. Or perhaps there are forms of matter and energy within the void that we cannot yet detect, altering the way light propagates through its darkness. What is undeniable is that the Bootes void's cold spot ties its story directly to the earliest chapter of cosmic history. When we look at this shadow in the microwave background, we are not just seeing emptiness today. We are seeing emptiness that has lasted for over 13 billion years. It has been hollow since the beginning, a gap written into the universe's blueprint, and because of that, the Bootes void becomes more than a curiosity. It becomes a test of our deepest theories, a puzzle piece that may hold the key to understanding inflation, dark energy, and even the possibility of other universes. To look into the Bootes void, then, is to look not only into space but into time, tracing a scar that stretches from the present all the way back to the moment of creation. Its cold spot in the cosmic microwave background is a reminder that the universe carries its history in light and that even emptiness can leave a mark. But the question remains, was this void always a single colossal structure, or could it be the result of something even stranger, smaller voids, merging together into one vast abyss? The Bootes void stands as one of the most haunting reminders that the universe is not obligated to make sense to us. It is a vast wound in the fabric of reality, 330 million light-years across, containing almost nothing where thousands of galaxies should exist. Its discovery shattered the assumption that the cosmos is uniform, revealing instead that there are regions where the rules appear to break, where emptiness dominates on scales too large to dismiss. But what makes the Bootes void even more unsettling is that it is not just an empty patch of sky, it is a living mystery, one that continues to challenge our models of dark matter, dark energy, and the very origins of cosmic structure. The 8 lonely galaxies drifting inside it are more than curiosities. They are survivors, testaments to resilience in the face of unimaginable isolation, evolving differently than any other galaxies we know. Their existence shows us that even in the most barren desert, stars can still form, though dimly, slowly, and with scars written into their very chemistry. They remind us that life, cosmic or otherwise, can persist in the harshest conditions, though altered by its solitude. But they also serve as a warning of what the future may hold, because their isolation is not unique to them. It is a preview of what all galaxies will one day face when cosmic expansion accelerates so far that every galaxy becomes stranded in its own island universe. The walls of the void, those dense curtains of galaxies pressed against its boundaries, highlight how emptiness itself exerts influence. Matter does not just avoid the void, it flees from it, clustering unnaturally at the edges, as if recoiling from a predator. This alone should force us to reconsider how gravity and dark energy interact, because it suggests that emptiness is not passive, but active, carving out structures and shaping the universe around it. The cold spot imprinted in the cosmic microwave background ties the Bootes void directly to the earliest moments of creation, showing that this region has been hollow for more than 13 billion years. It is not just a modern feature, but a scar written into the fabric of space-time from the beginning. Whether this was caused by fluctuations during inflation, exotic physics, or even contact with another universe, it stands as undeniable evidence that our cosmos is stranger than we ever imagined. And then there is the growth. The Bootes void is not still. It expands faster than the universe itself, as if emptiness has momentum, as if nothingness hungers. This acceleration suggests that dark energy may be more concentrated within it, or that we are witnessing the first signs of a false vacuum bubble, an alternate state of reality slowly consuming space. Whether or not such catastrophic scenarios will ever touch us, the possibility is chilling, because it shows how fragile our existence is in the face of cosmic forces we do not yet understand. What the Bootes void truly represents is a mirror. It reflects the limits of our science, the fragility of our assumptions, and the vastness of what remains unknown. For every galaxy we study and every theory we build, the void stands silently in the background, reminding us that the universe is not obligated to be simple or comforting. It is a reminder that even after centuries of progress, we are still explorers standing at the edge of a darkness that dwarfs our imagination. And yet, that is what makes it so profound. The Bootes void is not a dead end, but an invitation. It calls us to push harder, to build better instruments, to dream up bolder theories, to question everything we thought we knew about the cosmos. Perhaps one day, with next-generation telescopes, gravitational wave observatories, and quantum-level measurements, we will finally peel back the layers of this abyss. Maybe we will discover that the void is a relic of inflation, or a pocket of exotic matter, or even a scar left by contact with another universe. Whatever the answer, the search itself will change us, pushing the boundaries of science and philosophy alike. Because in the end, the Bootes void is not just about nothing, it is about the deepest something, questions about reality itself. As we stare into this abyss, we realize that the universe is not only larger than we imagine, but stranger than we can imagine. The Buddha's void is both terrifying and beautiful, a silent cathedral of emptiness that forces us to confront the scale of the cosmos and the fragility of our place within it. In studying this great nothing, we are not peering into emptiness at all. We are peering into the heart of mystery, and in that mystery lies the promise of discovery, the thrill of the unknown, and the humbling truth that even in nothingness, the universe speaks.